All right, good morning. Physics teachers are awesome. Today, I'm not sure where this is. My guess is this is not in the United States, just the way it's describing the class here. I don't know if you can see. There we go. Now you can see this title. But I was super interested in this AC phase difference in RC circuits. And note, by the way, this is a pretty short video, so I think they're really just going to focus on this demo. Let's see how it goes.
Everybody, this is a video for year 13 physics AC, and this is to show the phase difference when you have a capacitor and a resistor in a circuit. And Mrs. Khan is the one who set it up. So Mrs. Khan, would you like to explain?
Okay.
So right away, very cool, great framing, and just the camaraderie and the credit given. I think that's really amazing. Looking at this, I love it. Right, so they're using, I'm guessing, let's see, this is on, really low setting, and they're doing, can't quite tell where that's set. Looks like it's sinusoidal, really low amplitude. And it's just a circuit that goes through what I think they said was a capacitor, then an ammeter, then a resistor, and then an ammeter. But the ammeter might be being used as a voltmeter here. Kind of depends how they have it set up. But what's cool is for the phase difference stuff, all that they really care about is when does each one hit its peak. Very cool.
So here we have got an AC supply.
Yes.
And this one is the capacitor, and capacitor is in series with the resistor. That's a variable resistor. And these two meters, this meter is measuring the voltage across the resistor, and this meter is measuring the voltage across the capacitor. Now if we look at these two needles, which are showing the current at different times, and compare the position of this one and the position of
That's very cool. So when they zoom in, it's like, whatever, it's sinusoidal. But when they zoom out, you can see that they're not reaching the peak at the same exact time. And this is such a slow frequency. Let's see, it looks like it's like 0.3 hertz. Is that going to be slow enough? Let's see, 1 hertz, ding, 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 right? Yeah, okay, so so this is nice and slow enough they can really see. Super, super cool. And there's this pause where it's like, well, wait a minute, it's reading in microamps, but you're doing it as a voltmeter. Big deal, right? I'm sure the students have already seen and understood how to do that part of it. Really, all that matters here is when they peak out, and they've chosen such wonderful values of this amplitude so that this thing really does peak out. Oh man, this is really cool.
that one, and try to figure out which one is leading and which one is lagging. So
They are out of step, right?
So they are out of phase. They are not becoming maximum at the same time.
Yeah.
And if you look carefully, this one becomes maximum first, and this one lags a little bit. And if you do it exactly, this one will be lagging.
Sorry, usual problem with the autofocus on this camera. So notice how the camera is occasionally focusing on the finger. So frustrating. I'm sure they get frustrated about it too.
So voltage across the capacitor lags voltage across the resistor by 90 degrees, which is quarter a cycle, or pi by 2.
Yeah. Excellent.
And that's it.
Thank you, Mrs. Everybody,
Wow, that was super cool. I really love this demo. I guess I've never thought about doing such a slow frequency that you can actually talk about it as it's going. Because by the time you're into RC circuits, you're usually doing you're starting to think about like 60 hertz, which is, in the United States anyways, is the frequency of so many of the circuits around you. Doing 0.3 hertz, you can really stare at this stuff. I really, really like this. And I also liked the interaction between the two of them. I thought that was really great. They sort of finished each other's sentences, and the camera person was acting surprised with whoa, wait a minute, they're out of phase. So, wow, really, really cool. All right, everybody. Well, I hope you have a great day. And remember, physics teachers are awesome.